Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I want to give you another code review. On this code review, we're going to be looking at the SARIMAX method, part of stats waffles. And so, basically, what we're going to be using, we're going to be looking at the female births in California in 1959. And so, we're going to be using Google Colab. Google Colab is a free online Jupyter notebook that hosted by Google, and it allows you to program in Python in this Jupyter notebook. So that's a really great thing about Google Colab. The only thing about Google Colab that I find is a drawback is the fact that it doesn't have an adequate undo function. So basically, if you delete a cell, you can like undo a deleted cell, and then, but that's about it. And so like if you accidentally delete or overwrite some code, then what you can do is you can go into the save history, and when you look into the save history, there's a possibility that you might be able to retrieve the code that you've overwritten, which I've done it before. I've overwritten code before, and I've had to go into the save history and see if I could find it. So that's one thing that you can do to try to get code that you've deleted or overwritten. But the best thing to do is just to try not to do it. So after we've created this program, then what we want to do is we want to install the most current versions of stats models and other programs as well. So we do pip install NumPy, SciPy, Patsies, and Pandas. And then we do pip install stats models upgrade. So we're just making sure we've got the most current versions of these programs in the computer, because these libraries, they tend to make modifications, and when they make modifications, sometimes Google doesn't update the website as often as it should. And so, especially with regard to stats models, you need to make sure that you've got the most current version of stats models on Google Colab. So that's why if you're ever having problems with a library, it's always a good idea to upload the most current version of the library onto the system. So we've uploaded our most current versions, and now what we're going to do is we're going to import our libraries. We're going to import Pandas as PD, and that's your data processing library that creates and maintains data frames. We're going to import NumPy as NP, and that performs numerical computations, and it also creates NumPy arrays, and it also does linear algebra. We're going to import Math, which is an inbuilt library in Python, and it does more complex mathematics like square roots and things like that. We're going to import statsmodels.api SSM, which is the statistical library for Python. One thing that's interesting is that stats models used to be a part of SciPy, but then they made stats models a library in its own right. They're going to import Matplotlib, PyPlot, SPLT. That is a graphics library that will plot the data points onto a graph. We're going to import Seaborn as SNS, and that is it's a graphics library, but also performs statistics. So it's a higher level graphics package than Matplotlib, but it's written on the back of Matplotlib. We're going to import warnings, and warnings.filter warnings ignore. So we're just not going to see the warnings, because when we're running the program, you don't want to see warnings. It sort of like messes up the page and stuff, and you don't want to see that. So that's why we've imported warnings. So after we've imported our library, we want to read our CSV file, and we're going to use Pandas to do that. And basically, I found this car sales library on the internet, and I decided to use it because it was on GitHub. So we do series equals read, PD read CSV, and then that's the website address to the CSV file. index call equals 0, parse dates equals 0. So that means the first column is going to be your index and it's going to be time stamped. So now you can see what it looks like. You've got your index as your date and then your sales as your one column. So your index is your X variable and your sales is your Y variable. So we're going to plot it, and this is what it looks like when we plot it. So you can see that it has trend and it also has seasonality. So we're going to put it on a histogram. So this is what it looks like on a histogram. So this is what it looks like, a two view. So since all of the values were positive, you can put it up on two views, on both positive and negative, so you can see what it looks like, both positive and negative. So now we're going to do some statistics. We found that the maximum value was 26,099 and the minimum value was 5568. So there's your statistics. But you didn't really need to do that. If you wanted to do like df.describe, that would give you the statistics as well. But I didn't want to do that. I wanted to go ahead and make some statistics. Now what we're going to do is we're going to do some smoothing. And when you do smoothing, basically you take a rolling average. And I said window equals 12 because it's over it took a reading every month, and there's 12 months in a year, so that's why I just said window is 12. So now you can see what the time series looks like when it's been smoothed out, and you can see that it definitely has an upward trend. We're going to plot our ACF and PACF, and those are just autocorrelation. It just sees how the time series correlates to itself, but I don't know that much about it. I'll have to learn some more about that, I suppose. And then the same thing with the PACF, and this is your ACF and this is your PACF. So now what we're going to do is we're going to split the data frame. The data frame, the training set is going to be 90% of the data frame, and the test set is going to be 10% of the data frame. And then we're going to check the shape. So the train is 97 rows with one column, and the test is 11 rows with one column. Now what we're going to do is we're going to check the Holt Winters. And Holt Winters is basically, it's a really easy method to use, but it uses exponential smoothing, and so you have to have trends and seasonality in order to use Holt Winters. So we do have trend and seasonality in this data set, so we should be able to be okay with Holt Winters. So we trained and fitted the model, and then we checked our AIC, which AIC is another parameter that tells you how good the model is. And then we forecasted the model with y-hat, and then we checked our error. So we had an RMSE of 1930. We checked our actual values against our predicted values, and then we plot it on a graph. So you can see how the Holt Winters forecast is very similar to the test set, and the reason why is because it's going by past performance. So this is just telling you that if you have a data set that has trend and seasonality, then you can use the Holt Winters, and it's a very easy method to use. So now what we're going to do is, after we did the Holt Winters, we're going to check for stationarity, and basically what it's telling you is it's not stationary. It had a p-value of 0.66, and it has to have a p-value of less than 0.05 for it to be stationary. So what we did was we did some differencing to differencing is something that you do to try to make the time series stationary. So after we did the differencing, we reduced the p-value, which is what we wanted to do. and then we created an extra column in the data frame and called it stationary. So we got this extra column in the data frame, and this is what it looks like now. It looks stationary, but it still has a series to it. I still haven't figured out how, sorry, it still has seasons to it. I still haven't figured out how to get the seasons out of it. But this is reverse differencing, and this is just so you can see that if you're going to difference your data frame to take out the trend and the seasonality, and definitely the trend was taken out, but I'm not so sure about the seasonality. You have to do reverse differencing as well, and so this is reverse differencing, and so we have a sales column, a stationary column, and a reverse difference column, and you'll see that the reverse difference column is the same as the sales column. And then so you can see the sales plot and the reverse difference plot, and you can see that they're also the same. So now what we're going to check is for mean and variance, and this is also a stationarity test, because you have to, if your mean and your variance are very close together, then that means it's stationary. But you can tell that the mean of the train test and the test set is not close together, and the variance of the train test and the test set is not close together either. So that indicates that this is not a very stationary data set, even though we have done differencing. And the only thing that I could try to do is try to do differencing a second time. Do, like, instead of differencing one, do a differencing a second time, and see if that would take out the seasons, because when we did the differencing the first time, it took out the trend, but I think we still got season in there. I might try that and see what happens. And then we're going to analyze the test set, so you can see that the test set, this is what your test set looks like after it's been differenced. And now we're going to seasonal decompose. We're going to decompose the time series, so you can see the original time series, and then you can see the trend, so you can see that there definitely is a trend in that time series. You can see the seasonal, you see that there definitely is a season in that time series, and you can see the residual. That's kind of like a noise. So you can see that this still, even though I did differencing, I think maybe what I might try to do is do differencing another time and see what happens. See if that removes the seasonality. So now what we're going to do is we're going to look for our minimum values and our maximum values. And so, so our max values was 26099, and our min values were 5568. But I think I've already done that in the statistics, didn't I? Let's look. I think I've already done that. Yep, min S and max S. So that was just a redundancy. I didn't really need to do that. So I think what I'll do is I'll take that out since I don't need it twice. And now what we're going to do is we're going to split the data frame again. After we've done the whole winters test, we'll split the data frame. And so we split it between train and test. And so you can see that in this instance, train you had 97 rows by 3 columns, and test you had 10 rows by 3 columns. And the reason why is because after you did the differencing, we lost a bit, one of the rows of data. Because if you look at the first time, let's just look and see, the first time we did train and test, you had 97 by 11. But then what we did is we went and did the differencing. And when we went and did the differencing, we lost one row. And so that's why in this instance, you have 97 and 10 instead of 97 and 11. And now what we're going to do is we're going to look at the Arima. And this is the code to do the Arima. And so I get conflicting stories. One bit of code, it said it will go all the way up to 7. And then another bit of code, they said just set it for 3. So I'm just keeping it like this for the time being. But this is the actual code that you need to use to set up your PDQ. And the PDQ itself works. I'm not really able to get it to work on the SARIMAX, but it does work. And this is another thing. It's sort of, it's a type of Arima. It's like a seasonal Arima, so we'll leave Arima in there. And then this is the for loop that you use to iterate through all of the PDQ combinations, all of the PDQs, to see which one is the best one. And then it puts it into arrays, and then these arrays are converted to a data frame. And so because what we had to do was we had to, when we converted the different arrays to data frames, we had to create another column called temp and just fill it with ones. And the reason why is because we had to merge these data frames together to form one data frame and call it results. But then when we've merged all of the data frames together into results data frame, we didn't need temp anymore, so we dropped the temp. And this is just one way that you get around merging arrays together. You have to create an extra column called temp, and then you merge it on the temp file. And then so this is the results data frame. So 0, 1, 2 is your PDQ. Your OY is your RMSC, and your O is your AIC. And so RMSC and AIC, they tell you, the RMSC tells you the error, but the AIC tells you how good a model it is. And so you want to have a low AIC and a low RMSC. So basically, what we've done is we've looked for the minimum AIC. The minimum AIC was in row number 14, and you had 1808. And then you want to look for a low RMSC, and it was in row 54, and you had an RMSC of 18335. But any account is telling you to use a 0. And the reason why is because we got lots of warnings in it. And I think that that's because we didn't get rid of all the we didn't get rid of all the seasonality. But I'm going to work on that. I'm going to do something else and see if I can get rid of all the seasonality. And then after we've done all that, we use the actual stats models method, and we put 000 into the order because that's your PDQ. And then we get our RMSC of 1844. And now what we have to do is we have to make the predictions. And so we've made predictions on it. But then what we have to do is we have to reverse the differencing. We have to reverse the differencing. And so we reverse the differencing, and then so you can see that when we reverse the differencing, we can put it on, chart it on a graph, and you can see that this is the graph. And that's it really. We put it on a data frame, we check our RMSC after you've done a reverse difference, and you have 3596 RMSC after you've done the reversing. And then you get your actual values against your predicted values, and you get to look at that. So that's it really. The SARIMAX didn't work great on this particular data set. And I think that the reason why is because I wasn't able to remove the seasonality, but I'm going to try to difference it one more time and see if I can remove the seasonality if I difference it one more time. And I'll let you know. I'll let you know what happens. So I'm going to go ahead and conclude this video. I hope you got something out of it. I hope that you definitely learned the code, because I'll say that it's very difficult to code in stat models because there's code out there, but quite often the code doesn't work. And I've tried lots of code to get it to work, but this code does work. So you've got the code on your computer, and you can always take a pen and paper and jot the code down and then try it for yourself. So I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching my video, and I look forward to doing more videos for you in the future.